Hi everyone. In this video I wanted to speak to my SPSS friends out there who are interested in learning a little bit more about how to run analyses or set up data and run analyses using R. And one of the biggest hurdles that I found when I was learning how to use R was just the hurdle of understanding the data structure and how it's set up in R. Okay, so if you're used to SPSS and you've been using it for a while, you're obviously familiar with the drop-down menu system and really the ease in which a lot of things are accomplished. So, basically when you're setting up variables, there's a variable editor that's available to you. You can easily type things in and set up your variables and so forth. But in R, things are a little bit trickier because you really have to spend a lot more time telling the program what you want it to do. So what I wanted to do in this video is to spend a little bit of time on understanding data structure, and we're going to do this by way of setting up a data frame. So if you think about your SPSS data file, the spreadsheet that you open up to and so forth, it's got your values and your variables and so forth. You have to be a lot more explicit when you are setting something up like that in R. So I'm going to kind of walk you through just setting up a small data set. I'm going to be honest, most of the time when I am working with R, I'm going to import the data from a spreadsheet, maybe from SPSS, maybe from Excel, or some kind of file like that. So most of my data cleaning and stuff, I typically use other programs. But again, this is mainly to give you a sense of how the data are structured in R. So I'm going to start off with just a little SPSS data file that you can see right here. This is just a small data set that I set up. I intentionally included a few missing values over here just to kind of show you a couple of other things when we're creating this in R. So just again, for my SPSS friends out there, you'll notice that we have 6 columns. Each of those columns pertains to a variable, and then we have values on those variables, basically from rows 1 to 10. So if you click under variable view right here, you can see that when you were setting this up, or when I was setting this up, you'll see that I had a name column. I created names for each of those variables. We had to indicate variable type. The default is numeric. Some of the variables that I set up, you can see over here under measure, this is kind of indicating scale of measurement. Scale is typically assigned to interval and ratio level variables. In SPSS, it's kind of a catch-all in a sense. And then we've got nominal variables right here, and then an ordinal variable right here. And so for the nominal and ordinal variables that are categorical variables, what I did was I kind of created a little values for value labels, if you will. So you can see, like for my gender ID variable right here, I've got a value of 1 is equal to M, a value of 2 equal to F right there. And so if I run my analysis, those values will actually show up in the output. The same goes for eye color right here. I've got 1 assigned with a label of brown, 2 for blue, 3 for gray, 4 for green, and so forth. And then I'll just go ahead and show you, just to be complete, socioeconomic status, or SES. 1 is for low, 2 is for medium, 3 is for high right there. So we're going to set up this data set in R. And so I'm going to use the RStudio right here. I'll be honest, most of the time when I work with R, I'm kind of old school. I tend to use the original interface, but sometimes I'm asked about doing things using the RStudio, so I thought this might be an opportunity to do that. So we're going to start off we're going to create a variable, basically an object in R that contains the data for that interest variable. So I'm going to show you how to do this. I'm going to type in interest and then an arrow. That arrow is just basically a less than sign followed by a hyphen. And then we're going to type C, and then inside a parenthesis we're going to type the values for that variable separated by commas. So I'm going to type in 3, 2, 1, 2, 3, 5, 4, 3, 2, 3. Okay, so when I hit enter, what we have now is an object. That object is called interest. That's the name of the object, and it contains basically a list of values for that particular variable. So in R, just kind of keep in mind it's an object-oriented language, and what we do is we kind of perform certain functions, and then we can save those functions, or we can save data or whatever under various objects. So in this case, we've created our variable is called interest, but it's an object that contains this list of values right here. And the C that you see right here, this is a function. This is a generic function that basically combines values into a vector or a list. So that's all it is right there. So now if I type in interest right here and hit enter, you'll see that I get all of the values that I had typed in up here. So we have that object called interest with that information. If I type in, I'm going to create the gender identification variable. I'm going to call it GID, and then create, there's my arrow pointing to it, C. So we're going to create another list of values. And so now in this particular case, it depends on how you want to do this. I'm going to go ahead and instead of creating values and then later assigning codes, I'm going to show you that you can enter a list of string values. So in other words, so basically making this sort of a string variable. So I'm going to type in a quotation mark, double quotes, and then I will type in the first value, which is M, for persons identifying as male, end quote, then comma. Then another set of quotation marks, we'll put an F in between for those identifying as female, and then comma, and then we'll keep doing this. And I'm going to take a quick pause right here and finish this out. Okay, so now we have it. So you'll, again, just to reiterate, because this is going to be a string variable, we have quotation marks or double quotes around each value, and then each of those are separated by a comma. Now I'm going to say this is very important, that it's very easy to make a mistake. You inadvertently leave out a quotation mark or you leave off a comma, and you have to be precise when you are working with R. So just kind of keep that in mind, because it's very easy to end up with error codes. So I'm going to hit enter right now. And then if I type in GID or gender identification and hit enter, you can see those values in that list showing up. Now if I want to take a quick look at the characteristics of these two variables, I can do that. I'm going to type in str, and we're going to look at the internal structure of the interest variable first. So I'll type in str and then interest and hit enter, and you can see it says numeric. So you can see it's defining this variable as a numeric variable. If I type in str and then inside parentheses here I'll type in GID, then enter, you can see that this is registering as a character variable. Basically it's a, it's a string variable, and you can see all those values that are showing up. So now let's try another variable. We'll do the eye color in this particular case. So I'll type in eye color. This is my variable name. Again, my little arrow C. Now in this case we are going to I'm just going to assign use numeric codes first, and then later on I'm going to assign labels to this. And we're going to do this in the context of setting up our data frame. So right here I'm going to type in C inside the parenthesis 1, 2, 3, 2, 1, 3, 2, 1, 4, 4 right there. And then when I hit enter, and then we can take a quick look at it right here. There are the values. If I type in str, again, if I want to look at the internal structure, in this case, when I type in hit enter right there, you can see it's registering as numeric. Now that doesn't really make a whole lot of sense, because eye color is a nominal variable, but we're going to change this later. We're going to convert this to a factor variable later when we are setting up our data frame. So that's the eye color variable. I'll do the same thing for SES. So I'll type in SES, and I'm going to actually go ahead and pause this for a second and finish this one out, and also age, and then we'll continue. Okay, so I've created the object containing SES and an object containing age. And you can see again we've got our list of values for those variables right here. Once again, if I use the str function, str, and look at the internal structure of SES, it's actually going to register as numeric. And if I do the same thing for age, it's also going to register as numeric as well. Now now with the year variable, there are a few missing values. So I'm going to type in year. I'm going to create this variable, and we'll use our little C function right there, and I'll type in our values. But for missing values, I'm going to use NA. So that's how we're going to recognize that we have missing values. So I'll type in 1, 2, 3, capital NA. We aren't using a lowercase n a, we're using capital NA. NA right there, then 4, 3, 2, NA, and then a 9 right there. So we're using the NA the capital NA whenever we have missing data. Now we could obviously set up a missing value code. That's also possible. But for the purposes right now, we're just setting up a general NA which is essentially the missing values that we saw in the SPSS data set. So now we'll take another quick look at the structure right here. So I'll type in str, and then I'll type in year, and that's inside that parenthesis, and hit enter. And so now you can see we've got this is also registering as a numeric variable. There's 1, 2, 3, there's NA, then 4, 3, 2, NA, and then 9, and so forth. So now we have a set of variables, and I want to include them all in a data frame. So remember that in SPSS, we have this spreadsheet right here with these different variables with different variable characteristics and so forth. So, and we can accomplish the same thing in R by setting up a data frame that contains those variables. So to do this, I'm going to type in, I'll just create a new object that's going to contain all that information. I'm going to type in df. This is just going to be the name for that I'm using for the object. So I'm just calling it df for data frame, but you could call it anything if you wanted to. So I'll type in df and then an arrow right here. Now next we're going to use the data frame function. So I'm going to type in data dot frame right here, and then inside the parenthesis I'm going to type in the objects that we're going to be including in this data frame. Now it's important to keep in mind these objects, all of them have essentially 10 rows of data. They all need to have the same number of rows of data that are present, even if we do have missing values. So now what I'm going to do is I'm going to type in inside the parenthesis interest, then GID for our gender identification variable. Then we'll type in iColor, SES, age, year right here. So this is going to create a data frame with the 6 variables or columns again in that data frame. So we'll hit enter right here, and so if I type in just df, the object itself, you'll see that there's our data frame with those variables included. So now you can see that we have 6 columns of data, and each column is that separate variable. If I type in str and then df right here, in this case when I hit enter, you'll see that I get all the characteristics of those variables in that data frame. So you can see that we have interest right here, that's a numeric variable. We have gender identification here, which is a character variable. iColor numeric, SES numeric, age and year both are numeric. If I want to just look at one of those within the data frame, then what I need to do is to call up the data frame and reference that variable. And so I can type in str, and then inside the parenthesis I'll type in df, and let's say I want to just look at the characteristics of iColor. I can type a $sign and then iColor right here, and hit enter, and so I just get the characteristics of that variable in that data frame. So keep in mind that, and we're going to be doing this later with some other stuff, but basically if you want to just reference a single variable in the data frame, then you have to have the name of the data frame followed by a $, followed by the name of the variable that you're looking at. Again, iColor is not really a numeric variable as we would typically think, and we want to basically recode this basically so that we can treat this variable as a factor variable with and assign labels to those values of 1, 2, 3, or 4. Because remember that iColor right here, we've got these values of 1, 2, 3, and 4. So to do this, we will now we're going to create kind of a modification of that variable within this particular data frame. So what I'm going to do is type df and then a $, and then follow it up with iColor. So by doing this, I'm essentially going to kind of overwrite the original iColor variable in this data frame and essentially treating it as a factor variable. So to do this, I'm going to type in df $iColor followed by my little arrow right here, and then we're going to use the factor function. So I'm going to type factor right here, and then inside that I'm going to type in df $iColor. Okay, so what's going to happen is that we are referencing the iColor variable in our data frame, and this function right here is going to cause it to be treated as a factor. So next, what I'll do is let's say I want to, now if I don't want to assign value codes, I can just kind of stop right there. In fact, just to kind of show you, I'll go ahead and hit enter right here. And then if I type in str, I'll just go ahead and say df for the whole data frame. You can see that iColor now is registering as a factor variable with 4 levels. Now if I want to add those labels, I can easily do that as well. I'm just going to go back and overwrite what I just did. So I'll type in df $iColor. There's my arrow followed by factor, df iColor, comma, and now I have to indicate how many levels there are. So remember that there were 4 levels, so I'm going to type in levels equals, and then we're going to create another list of those levels, those values for the levels. So I'll type in C. So we're creating a new list, so we're using the C function here. Inside a parenthesis or new parenthesis, I'm going to type in 1, 2, 3, 4. We have our end parenthesis, and then we're going to add another comma. So next we're going to type in labels equals, and then a C for a new list right here. And so now we're going to type in those values or the labels. So because we're assigning iColor brown, blue, gray, green, what we're going to want to do is to include these value labels inside parentheses. So I'm going to go ahead and start the first one. I'm going to type double quotes, then brown in double quotes. Now you'll see that right here we kind of went to the next line. If I kind of scoot this over a little bit in RStudio, it kind of just went to the next line right here, and so then we kind of start from there. So I'm actually going to go back to brown right here. I'm going to add a little comma here, and then I'll hit, oops, there was a little bit of an error right there. So let's do this again. We'll just type in iColor, and then our arrow, then factor, then df iColor, and then we'll say levels equals C, and then 1, 2, 3, 4 right there, and then we'll type labels equals C, and inside the parenthesis there I'll type in, let's see here, brown, and then we'll have a comma outside that. We'll start the next one with blue, so blue inside that one right there. We're going to add a comma, and then we'll type in gray inside those double quotes, comma, and then green next right there. So then notice that because we started this list, you always have to close out each of those lists. So that we started the list, there's brown, blue, gray, green, so there's an end parenthesis right there, and then we need a final parenthesis to close out this entire function for the factor. So now when I hit enter, it's all good to go. So now if I type in str and then inside parenthesis here, we'll just go ahead and type in df. I'll go ahead and reference iColor specifically instead of asking for all of the variables. You can see that now it says factor with 4 levels, brown, blue, and so on. Okay, so now let's try another one. We're going to recode SES. We're going to treat it as an ordered categorical variable, and we're also going to assign value labels to that variable. So to do this, what I'm going to do is go type df and then a $, and then we'll type in SES and then our little arrow here. And there's actually a couple ways to do this. One option is to use the ordered function, and another option is to use the factor function and then indicate an option in terms of ordered being true or not true. So I'll show you kind of both ways. So I'm going to type in ordered. So this is going to be a new function. We'll type in ordered, and then inside we'll type in df $SES. I'll go ahead and assign the value label. So we'll go ahead and first off we have to indicate how many levels there are. So I'll type in levels equals C. So we're creating a new list. And then inside that, the actual levels that we have in our data set, which are 1, 2, and 3. So I'm going to type in 1, 2, 3. And then outside of that parenthesis, I'm going to type a comma and then labels equals C. And inside the parenthesis, I'm going to type in quotation marks. We'll do low, and then we'll have another comma, and then new set of quotation marks. Actually, we'll type in low SES. Right there. Then we'll type in med SES right here, and then another comma, and then inside the last quotation marks I'll type in high SES right there. Now, so remember that anytime that we have a list, whether it's right here, whether it's right here, or any of those others above, we have to make sure that we close out each of those lists, and then we also have to make sure that we close out the original function. In this case, the original function is that we are treating this variable as ordered categorical. So the function that the main function right here is ordered. So we have basically kind of a macro function, if you will, which is this right here, and then we have some functions embedded within that. So now I'll hit enter, and so if I type in str df $, and we'll type in SES right here, you can see that now it says ordinal factor with 3 levels. And then there's the names. You can see low SES, medium SES, and so on. And then these are the values actually in the data set right there. So if I type in df, in this case, I'll type that in. Actually, now you can see that we have our interest variable. There's our gender ID variable right there, iColor. So you can see that the labels are now showing up in the data set. So there's brown, blue, gray, and so forth. For SES, we've got low SES, medium SES, high SES, and so forth. And then our age and year variables are exactly the same as before. Once again, because we had some missing data on the year variable, there's those cases that are missing values on that variable, we have NAs for those. And just so you know, option B with respect to that SES variable, we could also use the following. We could have typed in df $, and then SES. There's our little arrow there. And instead of using ordered, we could just type in factor, and then df $, SES levels equals C. Inside the C, we have 1, 2, 3. And followed that parenthesis up with labels equals C. Inside our parenthesis here, we have our quotation marks, low SES, there's a comma, and then a medium SES end quote, then our high SES, end quote there. We end that list, and then we can type comma and then ordered. So there's an option right there. We're going to type ordered equals true, and so if I hit enter right there, then basically we're going to end up with the same thing. So if I just type str again df $ses, then you can see again it's registering as an ordered factor. Now, unfortunately, you can see we have these NAs right here, and the reason why is I just realized because those values of 1, 2, and 3 are not in the current version of our data frame. Remember that previously up here we had converted those values into low SES, medium SES, and high SES, and so when I went down here to try to use the same data frame, it created a problem because we didn't actually have values of 1, 2, and 3, which were the levels that I was referring to right there. So just kind of keep that in mind. That was a little bit of an error on my part. I can just kind of reiterate that. I'm going to actually just really quickly, I'm going to convert the SES back to having those original values right there. So I'll hit enter. So again, I just kind of reference that SES variable within the data frame. This is the list of values right there. Just really quickly, I'll show you. If I type df, you can see those values now have reappeared under SES, and then we can use this approach right here. So in fact, I'll just go ahead and do that. I'm just going to copy and paste it right there, and then we'll type in str and then df $ses right here, and you can see right here it says ordinal factor with 3 levels, low, medium, and high SES by extension, and then those are the original values that we were talking about. Okay, so at this point you might be curious about situations where, let's say you want to drop a variable or variables from a data frame. You can do that as well. So let's say that I want to drop the interest and age variables from this data frame. Remember, our data frame, this is what it looks like right now. So if I want to drop those variables, what I can do is I'm going to type df, and let's just say I don't want to save over the original data frame, but let's say that I'll create a new data frame without those 2 variables. So I can do that. I'm going to just create a new data frame called df1, just very nondescript labeling, of course, but so this object is going to contain the original data frame that we just set up here, minus the interest and age variables. So if I type in an arrow right there, then I'm going to use a subset function. So I'm going to type in subset and then parenthesis, and I'm going to give the name of the original data frame. I'm just going to call it df, that's the original data frame, comma, and then we're going to use a select option right here. So we'll type in select equals, and then we're going to type in minus C. So remember, the C is for a label, so in this or for a list. So in this case, we're going to be removing our 2 variables, which are interest and age. So I'm going to type again, there's a minus C, and I'll type in interest, comma, and age right there. We have our end parenthesis, and then we, for that list, and then we have the last end parenthesis for that entire subset function. So when I hit enter, you can see that if I type in df1, you can see that now the interest variable and the age variable are no longer in the data set. Okay, so another option I'll show you is let's say that you want to remove certain cases from your data set. So let's say you have cases 1, 3, and 10 that you want to remove for whatever reason. You can do that as well. So what I'm going to do is I'm going to go back. Remember that we're going to stick with the original data frame, just to show you again what that looks like. df. There's the original data frame. It's got the interest and age variables in there. But what I'll do in this case is I'm going to create another data frame removing cases 1, 3, and 10 from this data set. So to do that, I'm going to, and So I'm going to type in df new. So we're just creating a new data frame right here without those 3 observations, but with everything else. So I'll type in an arrow right here, then df, so that's the name of our original data frame. I'm going to create basically creating a square bracket, and inside that I'm going to type minus C, so we're creating yet another list right here. Inside the parenthesis I'm going to type 1, 3, 10 right there, in parenthesis, and then an end of the square brackets. So just to reiterate, I'm creating a new data frame. I'm just calling it df new, that contains the original data frame, but I'm removing cases 1, 3, and 10 from that data frame. And so to do that, I have a minus C, and then 1, 3, and 10 are the are essentially the row numbers, if you will. So we'll hit enter right here, and then I'll type in df new so we can take a look at it, and you can see. Okay, and you can see that actually this did not work, and there was one little error that I forgot, and that is that you have to add in, believe it or not, at the end of this list right here, there needs to be a little comma following that in parenthesis. So let's try this again. My apologies for that, because it's very subtle, and like I said, if you're not precise, it's not going to work for you. So I'm going to type in df new, df bracket minus C, inside the parenthesis 1, 3, 10 in parenthesis, and then a comma at the end followed by that bracket. So now when I type in df new, you can see that cases 1 and 3 and 10 have all been removed from this data frame. Okay, so now what I want to do is just transition a bit and just talk about a couple of other general functions in R that you might find helpful. So first off, right now we have a workspace with a number of different objects that are contained in that. If you guys remember, earlier on when we were creating that original data frame, we had set up essentially vectors for age, eye color, gender ID, interest, SES, and year. Okay, so those are all right now. Those are all still active in memory, and we also created multiple data frames that we were working with. All of those are active as well. If I want to see the entire list of objects that are currently kind of in the workspace, if you will, I can type in or use the ls function. Ls is basically kind of listing, so I'll type in ls and then a parenthesis. So nothing inside the parenthesis there. I'll hit enter, and so now you can see everything. We've got age right here. We've got the df data frame, the original data frame. There's interest, SES, year, eye color, there's our gender ID variable right there. All of those were again used to originally set up the first data frame, which we called df, and then we made modifications to the original df data frame, so we called it df1, and then there's df new right there. So this listing can be helpful, so you can kind of get a better idea about what's currently active in the workspace. And the reason why that's going to be important is because when you're running various statistics, a lot of times you're having to call on data frames that are currently, or other objects that are currently active in the workspace. And if they're not active in the workspace, even though you might try to type in the object into whatever function you're using, if it's not in the workspace, you're not going to be able to use it. So that's going to be really important. It's basically the same as if I go back to SPSS and I try to run an analysis with a variable that's not there. You're not going to be able to do that. So the same basic principle is at play when you're talking about R. All right, so now let's say that I want to remove one of those objects. So you can easily do that just by using the rm function. We type in rm, and inside a parenthesis we have to actually give the name of the object that we want to remove. So let's say I want to remove the df new variable, that last one we created. I can type in in this case, I'll type in df new. So that's the name of that object that we had created last, and then we'll hit enter. And so now if I type in ls and then the parenthesis here and hit enter, you can see that df new is no longer active in the workspace. You can also remove all objects from the workspace if you wanted to. That's very easy. You can just type in remove, and then inside of parenthesis just type list equals ls, and then parenthesis there, nothing inside it, and then make sure there's an end parenthesis because you're speaking to the entire remove function right there. So we'll hit enter. And now if I type, you can see that the environment actually is now empty on the right. If I type in ls and then that parenthesis there and hit enter, you can see nothing shows up. So I've removed literally everything that I've done up to this point from the workspace. Okay, a couple of other things that I wanted to show you too concerns how to save objects from your workspace and also how to load them. So really quickly, what I'm going to do is I actually have all those commands that I've used earlier. I'm going to recreate that original DF file. And so here we are. There's all that information right there. So there's the original DF file right there. So again, I had all this already typed out. In fact, what I'll do is I'll share, there's actually a document that I had created, a little notepad with the commands I've been working through in this presentation. So you can go there and look at it. I'll just include that as a link underneath the video description. So at this point, let's say that I want to save this, this data frame, this information, the variables and everything that I've already been working with, or perhaps if I create other objects, like I run some analyses and I want to save results from those analyses, I can create new objects that would also be within the available workspace. So, but right now we're just going to be focusing in on saving, what we've done with respect to this first data frame. So the first thing to keep in mind is that you need to have, if you're going to be saving or even or calling up anything for that matter, you need to make sure that you have R pointed to the folder on your computer where you're going to be saving or calling things back up. So that's going to be the first thing to keep in mind. So right now, because I'm under RStudio, there's actually a really easy way to point the directory, if you will, and that's just to go under session, and you can see it says set working directory. So you can go down here, it says choose directory, so I'll click on that, and right now I actually have the directory already basically we're already pointed to an R folder in my documents folder on my PC. So if I wanted to change this, I could go to whatever other folder, and it's going to be pointing to that particular folder. So this is really the easiest way to kind of move around. Actually, if you're under the original R menu, there's also a set working directory option that is really easy to use. Otherwise, you'd have to use a little bit of code, which you can certainly use, but this is really a lot easier. So what I'm going to do is hit open right here, click open, and basically that's just because we're already there, so I'm not moving around or anything of that nature. So if I type save and then inside the parenthesis df, so this is the name of the object that I want to save to an R data file. So if I type comma file equals and then parenthesis and then quotation marks, I give the name of the file that I give a file name for the R data file. So I'm just going to go ahead and call it DF for lack of a better naming system, dot, and then type in the extension, which is R data, and then end quotation marks, and then end parenthesis here. So just remember that we have to close out those parentheses because our function is a save function to the left. So we're saving this data frame that we had called DF in a file, basically an R data file, and that R data file is called DF. So again, that's just my little naming here. So at this point I'm going to hit enter, and so now it's been saved to an R data file. So if I go to file and then open file right here, you can see that under my R folder, you can see that now we have this DF. That's the R data file that actually contains our data frame. If I want to, just for completeness, let's try one more. Let's add one more object to our space and then resave it that way. So I'm going to save, or actually what I'll do is I'll create a new object. I'm going to call it fit and then an arrow. This is not in the commands I was mentioning, by the way, but I'm just going to create this object. I'm just going to run a linear regression. So in this particular case, we'll type in interest as a function of, we'll just use age right here, and then we'll refer to our data frame. So I'll type in data equals df right there, and when I hit enter, and so just really quickly, you can see that if I use a summary function right there, there's the regression results. But the main point that I wanted to make right here is that I now have created a new object that's called fit. And so here I'm using the summary function with that fit object to see all of my results. So now I have two objects that are currently in working memory. I have df and fit, but fit has not been saved to that R data file. So if I wanted to save that, I can do that very easily just by typing save. Let me go down here and we'll type in save. Inside the parenthesis we'll type in df, then a comma, and then I'll type in fit right here, and then comma, and then we'll type in file equals, and then I'll just call it again df. I'm just going to overwrite the previous one. Our data right here, there's our in parenthesis right there. So now when I hit enter, that information is both df and fit are saved to this R data file. So both of those objects are contained in that R data file. So for completeness, what I'll do is really quickly, I'm going to remove everything just so you can see what it looks like. I'm going to remove everything. So I'll type in remove list equals ls parenthesis and end parenthesis there. So we've cleared the entire environment out. Once again, if we take a look to see if there are any objects, there are none that are present. Now if I go back to file and then open file right here, we will open up our workspace, that our data file called df. We'll click on open right here. It says, do you want to load the R data file? So I'm going to say yes. And so now you can see that the objects that are contained, there's the df, there's our data file, and then there's our fit object that contains our regression results. So in other words, if I wanted to type in ls and then parentheses there, nothing in between, and hit enter, you can see that now we have those objects df and fit right here. Okay, so that pretty well wraps up this particular demonstration. Again, this was mainly for my SPSS friends out there who might want to get acclimated to using R. Again, one of the biggest learning curves is understanding how data is structured, how to set up a data set, and how it's structured. Once again, I typically end up importing data from other programs and then running whatever analyses through R. I just find it really less of a headache than trying to kind of set up a data set like we just did here. But again, hopefully through this walkthrough you've gained a better understanding of how data are structured in R, and a little bit about just kind of how to work with objects using the R program. So that's going to conclude this video presentation, and I appreciate you watching.